parallel lines in the triangle, then what I can do is I can write a proportion or a fraction for the two sides of the triangle, and they should be equal to each other. So in other words, if DE, right here, if DE, if this piece is parallel to this piece, what's the symbol for parallel? You know the symbol? So arrows on the picture, how do I write parallel without actually writing the word parallel? Oh, not equal. Just two straight lines. They literally look parallel. So if DE is parallel to AC, if these two lines are parallel to one another, then I can write a proportion or a fraction for the side lengths that are not the parallel sides. So in other words, I can write a fraction for these two sides that are on the left, BD divided by DA. So that's the small piece divided by the larger segment on the left. Which two pieces would match up on the right? So what's the smaller piece on the right side? BE. And then what's the other piece of the segment on the right? EC. So I can write two fractions and they should be equal to each other if they're parallel. The converse means just the opposite. So that says if you can write the fraction and the fractions are the same, then the lines have to be parallel. So you can go kind of either way. So if BD over DA is equal to BE over EC, so if I have those two fractions again, automatically my two lines have to be parallel. DE has to be parallel to AC. All right, so there are a lot of questions. We're not going to do all of them right now together. We're going to do just the odd problems together, okay? And then you guys are going to work on those even problems on your own. So we're going to use these proportions right here to help us with our fractions. And you're going to go, wait, this is the easiest thing we've ever learned. I'm going to go, I know, crazy. All right, so take a look at number one. You've got your two parallel pieces. They've got the arrows on them. I want to make fractions for both sides of the triangle. So here's one side of the triangle on the top. Here's one side of the triangle at the bottom. I need to make a fraction between the two. What would one of the fractions look like for one side of my triangle? What divided by what? 14 divided by 12. Very good. Those are two pieces on the same side. Equals. Now I have to pick the other two, but they have to go in the same order. So since I picked 14 first, am I going to pick the x first or the 15 first? The x first. Equals x over 15. So my proportion is 14 over 12 equals x over 15. And now you've got two fractions. You've got an x value. You're trying to figure out what do I have to do with my two fractions now? Cross multiply, cross multiply, or multiply diagonally. So what is 12 times x? Equals, what's 14 times 15? A big number. 210. Hey, there's your equation. What do I do now? It's just algebra. Divide by what? Yeah. What's your x value? 17.5. Notice you definitely want a calculator today. Okay, and that was it. You're finished. You did it. Hooray, proportions. Right? I told you this is like the easiest thing in your life. Okay, so as long as it doesn't matter which one you put on top, like 14 over 12 or 12 over 14, does not matter as long as you keep the order the same in the second one. Okay? All right, so let's take a look. Like I said, we're only going to do the odd problems. Number 3. What's different about number 3? Versus the last one we just did. One of the sides, this time I'm telling you the whole thing is 55. but I need to know the two smaller pieces in order to write the fraction. How am I going to figure out what this little piece is right here that doesn't have a marking? Yeah, exactly. This is saying, look, this whole thing is 55. I've used up 45 of the 55. What does that mean is left over to get me to 55? So essentially, I just do 55 minus 45. What does that give you? 10. So if I were to add together 10 plus 45, I would get 55. Now you've got your pieces. Now I can write a fraction. What would one of my fractions look like? So two pieces on the same side. 10 divided by 45 equals, keep the same order on the other side. X over. Beautiful. And now, just like before, cross multiplication. Doesn't matter which one you do first. So what's 10 times 36? 360 equals, what's 45 times x? 45x. What's my only step? Divide by what? Good. Told you it was going to be easy. What do you get? X equals 8. Okay, or 8 equals x, whichever way you want to write it. And you're done. Told you it wasn't a hard day. Just some algebra. It's literally the hardest part of this whole thing is making sure you write the fraction in the right order. That's the hardest part. Because after that, it's just algebra. All right, questions there before I go on. Okay, number 5. Now, don't let number 5 freak you out. Still the same setup. You're going to pick two numbers on the same side to write a fraction. What would my fraction look like? Or what's one of my fractions?
25.
Good, 25 and 15. There's one fraction. Okay, what is my second fraction? Keep it in the same order. So you did the top one divided by the bottom one.
30 over x.
Exactly. Equals 30 over x plus 7. Don't let it freak you out. It's the same thing. We're still going to cross multiply. So first thing I'm going to do is 30 times 15. What do you get? 450 equals. Now, the only part that's different here is instead of me multiplying by just an x, I have to multiply by the entire x plus 7. So I have to multiply 25 by both the x and the 7. So in other words, I'm taking this 25 and I have to give it away to the whole equation, x plus 7. If I'm giving it away to the whole equation, what are you really doing? You're distributing. Yeah, you're taking that 25, you're giving it to the x, and you're giving it to the 7. Don't forget to give it to both, because you can't just give it to one piece, just give it away to the whole thing. Now it's an algebra problem. I'm going to start by distributing. What's 25 times x? What's 25 times 7? 175. Good. And now it's just algebra. So what should I move first? Yep, move that 175 over to the other one by subtracting. So this gives me 275, yep, equals 25x. And then my final step, divide by 25. What do you get for your x value? 11, good. And that is truly as hard as it gets because I gave you an equation there. But again, hardest part is just, can you write the equation or can you write the proportion in the right order? That's the hardest part. After that, it's straight algebra. Okay, give me a thumbs up, thumbs down. How you feeling right now? Your thumbs to the side. See, 2 thumbs, 3 thumbs, 4 thumbs. Okay. All right. We're hopping on over. We're moving over, right? Because I told you I'm only going to do the odd problems with you. Now, in numbers 7 through 9, it says determine if the 2 lines are parallel. So what you'll notice for these problems is I give you all 4 of the sides. There's no x to solve for. All I want to know is if they're parallel or not parallel. If they are parallel, then my fractions should be the same. They should be equal. If they're not the same, guess what? They're not parallel. So all I'm going to do is check them with some quick division by making some quick fractions. So if you take a look at number 7, what is one of your fractions going to be? 11 over 15.4. That's one fraction. I want to check and see, is that equal to the other fraction? What's the other proportion? 10 over 14. Yeah. And just like I did with my similar triangles before, all I'm going to do is divide the 2 numbers. I'm going to get a decimal, and I'm going to see, are those decimals the same or are they different? So I'm just going to straight up put it into my calculator, because I don't know what that is off the top of my head. So what'd you get when you do 11 divided by 15.4? 0. I'm just going to put 7.1. Okay? Good. And then try the other one. Did you get the same thing? Yeah. So they are exactly the same. Are they parallel or not parallel? They're parallel. So I'm just going to put the marking on my picture. I'm going to write parallel. Hooray. Easy stuff, right? Easy, easy. Okay, can you try number 9? We'll see if we get the same answer. What do I have to do for number 9 before I can write my fraction? I have to do it. Yeah, I have to take these 2 numbers and subtract them. So it's 54 minus 24. 30. Okay, you write your fractions. Let's see if we get the same answer. Write your fractions and divide them. I'll give you a second to try. Let's see if we get the same thing. Mm-hmm. Yeah. Should the password thing. Thirty more seconds. Look up when you're done. Okay. All right, show me with your thumbs. Are they parallel or not parallel? What'd you get? Yes or no? Got some no's, got some yeses, got some nothings. So it should be yes. Parallel. 30 over 24 is equal to 37.5 over 30, or you could have flipped it the other way. Did anybody flip it the other way? You could have done 24 over 30 and 30 over 37.5. You would have gotten, I think it's like 0.8.
Yeah, I got 0.0.
You should have gotten 0.8 for both of them.
I got 1.25 and then 0.
Which tells me that what you did is you flip-flopped. You did one, you probably did 30 over 24 and then you did 30 over 37.5. You flip-flopped them. You didn't do them both in the same order. when you divide it.
30 over 24 equals 3.7 over 30.
It's 37.5 over 30, that's why.
Oh.
I think you're at the wrong number.
Yep.
That'll do it.
Okay.
All right. Good. Questions there? Not too hard, right? All right. Now, next one. Proportional parts of parallel lines. Can I have somebody read this next theorem? Proportional parts of parallel lines. Who'd like to read? Anyone? You will learn. Is he old enough to know that? No one? Anyone? Cool, you guys are killing me. All right. If 3 or more parallel lines intersect 2 transversals, they cut off the transversals proportionally. Essentially, this is exactly the same thing we just did, except instead of it being a triangle, it's now parallel lines. But it's the exact same thing. You can still write proportions if the lines are parallel. So, in my picture here, if AB, this line right here, AB, and I put my little arrows above it. If line AB is parallel to line CD, which is also parallel to the last line, EF, so if I give you 3 lines that are parallel, then you can make a proportion for the sides, just like we did before, that are equal. You take 2 sides on the same line. So in my picture here, I've got AC divided by CE. This piece divided by this piece should be equal to what? Same order on the other side. What would that be? So this piece, AC, divided by this piece, CE, is equal to what? BD and DF. Good. This piece, BD, over this piece, DF. It is literally the exact same thing we just did, except instead of it being a triangle where they're closed, it's just some open lines. But it's the exact same thing we just did. So let's take a look at number 11. I'm going to keep the proportions the same. 2 pieces on the same side are equal to 2 pieces on the opposite side. What would one of my fractions be? 12 over, keep it on the same side.
12 over 30.
12 over 30, here's one side, equals, yep, and then keep this other side in the same order. So 14 over x, good. And then it just becomes algebra again. Cross multiplying. I hope you're noticing you're doing the same thing over and over and over and over and over again. All right, so when I cross multiply, what's 12 times x? What's 30 times 14? It's a big number. 420. Okay, one step. How to get the x by itself? Divide by 12. I get x equals, was it 35? 35, right? Yeah, 35. That's it. Easy peasy. It's exactly the same. So you always pick 2 fractions that are on this, or 2 numbers that are on the same side. All right, let's hop down to 15. Do I have questions on that one? Let's hop to 15. 15 is the hardest. 15 is literally the hardest that it gets. Okay, so we're doing the same thing. 2 numbers on the same side, and we're going to write it as a fraction. What would one of my fractions be? Beautiful. This side on the left is 2x plus 2 over 21. Good. If I put it in the same order on the right, what over what? Beautiful. X plus 3 over 12. Now, the only reason that this problem is considered any harder is because instead of it just being one equation, you've got two equations. But don't let it freak you out. You're doing the exact same thing. We're going to cross, whoa, that's the wrong way. We're going to cross multiply. Now, before I cross multiply, what Mr. Massa always likes to do is anytime I see an equation, I put it in parentheses. Okay, so like this equation, 2x plus 2, I'm going to put it in parentheses. This equation, x plus 3, I'm going to put it in parentheses because that way I know I'm not going to mess anything up. I know I'm going to make sure to distribute everything. Okay, so what are the first two numbers I'm going to multiply together if I'm cross multiplying?
X plus 2 divided by
Times 12. Times 12. Yep. So I'm going to multiply these two together. Now, when I multiply them, I always take the number that's by itself. I'm going to put it first so that I remember to distribute it. So I'm going to put 12 times parentheses 2x plus 2. And I'm going to set that equal to what? 21 times x plus 3. Good. And now it's an algebra problem. And the only reason that it's a little bit harder is just because you have to make sure you distribute, and you're going to have to distribute 2 times, right, on both sides whenever you see the parentheses. So I'm going to take this 12, I'm going to multiply it times everything in the parentheses. What's 12 times 2x? What's 12 times 2? 24. Now I'm going to do the same on the right. What's 21 times x? 21x. And what's 21 times 3? Good. And now you should feel way more confident because now it's just some quick algebra. I get all my x's to the same side, so which x should I move? 21. By doing what? Subtracting, because it's a positive. All right, and then I'm just doing some quick algebra here. So 3x plus 24 equals 63. And then I'm going to subtract that 24 from both sides. Wait, 39. 3x equals 39. And then I divide both sides by 3. X equals 13. Perfect. Okay, so that is truly as hard as it gets, honestly. And again, the only reason that that one was harder was because you had to do 2 distributions. But again, it's still the exact same thing. You're still just making 2 fractions and cross multiplying. That's all we're doing. 2 fractions and cross multiplying. All right, let's flip it over to the back for our last section. And then I'm going to give you, hopefully I'll give you enough time here to kind of quickly move your way through the even problems. All right, the last theorem is the triangle bisector theorem. What does bisect mean? Cut in half. Very good. So maybe I'm going to write that next to bisector. Cut in half. All right. So if you are given a bisector in a triangle, if I tell you that something is being cut in half, then you can make some proportions just like we did that show which pieces of the triangle are congruent. So in this case, if I look at my picture, BD is my bisector, and it cuts the triangle in half. It cuts this angle in half up at angle B, which is why it's got the arc marks there, because it's cut in half. They're the same. What I'm going to do is I'm going to write a proportion about the 2 sides that are across from the bisector. So if you come up to the angle, draw an arrow straight down, you should have 2 sides across from the bisected angle. What are the two sides that are across from the angle? AD and DC. That's going to be my first fraction. This piece here, AD, divided by DC. That's the bisected pieces right across from them. I'm going to set that equal to the other two sides of my triangle, AB and CB. And whatever order I did first here, I have to do first on the second side of the triangles. So since I chose side AD first, should I choose side AB or side BC? AB is on the same side of this triangle, so I'm going to pick AB first. And then I'm going to pick this side over here, BC, as my last one. So your first proportion, these two are always the ones that are across from the angle, from the bisected angle. So if you can find the, sorry, should zoom out, my bad. Across from the bisected angle, this is my first two fractions here. And then the other two are the two that are left over. So let's take a look at number 17. You will see the angle is not marked for you. Which angle is being cut in half in number 17? Angle which one?
KM.
Yep, KM is my bisector. So angle K right here where they share. This is my angle that's being cut in half. Right where the two meet up together. Now let's go to the sides across from the angle. So Ms. Masso always draws her arrows going straight across from the angles. Which two sides are across from the angles? From the bisected angle? JM and ML. Good. These two numbers, 40 and 36. Does not matter which one you choose first. I'm going to do 40 over 36. Equals. Now, this is the part that matters. Now I have to pick the sides that are left over that match in the same order. Good. 54 is on the same triangle as the 40, so 54 comes first. X is at the same one as 36, so X comes last. And now it's just like what we did before. It's just cross multiplying. So what's 40 times X? And what's this big number? 54 times 36. What is it? 1,944. Okay, I'm just going to take your word for it. 1944. And then what's my last step? Algebra, divide by 40. Easy peasy. I do not know what that is off the top of my head. 48.6. Beautiful. And you're done. So again, hardest part is just making sure you set up your fraction correctly. Once you set up your fraction correctly, it's just cross multiplication. It's just some algebra. All right, last one, number 19. Okay, just like before, KM is the bisector. Which angle is being bisected? Which angle do they meet up at? Angle K at the top. Or technically, I guess, the bottom. All right, we're going to go directly across from K. Directly across. Which two sides are across from K? JM and ML. Okay, now I've got a little bit of a problem. What's my problem? Right, I only know 12 and I know X is the whole thing, but I don't know what this piece is. So my first fraction is supposed to be these two numbers divided by each other, but I only have one of the numbers. I don't know what the second number is. So that's a problem, isn't it? Because then how can I write a fraction without it? Now, what? Plug in X. Well, this is not X. This whole thing is X. So here's this. Ready? Back on the front, we did this before. We had a problem, number 3, where I told you the whole thing was 55, And I told you this one piece was 45. What did we have to do to get this piece 10 over here? We subtracted. We said, hey, I know the whole thing. I know a piece of it. If I subtract the piece, that's going to give me what's left over. We're going to do the same thing for this problem. I'm going to take the whole thing and subtract the piece that I'm given. What's the whole segment? X. What's the one piece I know? 12. So what I'm going to do is I'm going to take the whole segment X and I'm going to subtract 12. That's going to give me what's left over. And now I can write my fraction. What should my fraction be? 12 divided by X minus 12. It's just an equation. And I set that equal to the other two sides in the same order. So which one should go on top? Good. 18 over 30. And now it's just, again, algebra. But you do have an equation, so I should put it in parentheses. And I'm going to cross multiply. So what is 20, excuse me, times 30? Or sorry, 12 times 30. Come on, Mr. Masso. What is it? 360 equals, now I'm going to do, remember, this is an equation, so I'm going to do 18 times the whole equation, x minus 12, which means I'm going to have to do what? Distribute. Very nice. Okay, so what's 18 times x? 18x. What's 18 times negative 12? Negative 216. Good. And now it's some quick algebra. I add the 216 to both sides. I get 576 equals 18x. And then I divide by 18. I get x equals 32. Beautiful. And I'm done. Truly, truly, that's as hard as it gets. It's just cross multiplication. All right, now, I know we don't have a lot of time left, but we got about 10 more minutes. You're going to take the time right now to get as many problems of the even ones done as you can. We're going to check the even ones tomorrow as our first thing that we do in class. Okay? So you are responsible for the even problems right now. Right now, you should be able to get through a good chunk. And then if you don't finish those even problems, you're going to do them for homework and we're going to check them tomorrow. Okay? All right, so go ahead and get yourself started. It's just a whole bunch of fractions. That's really all you're doing. A lot of proportions. So I'll zoom out. I'll keep these ones up for you. And I also already have my odd problems up online in case you missed one. Okay, but take some time right now. You guys can get going. Even problems.